A general AI model knows a lot about the world, but nothing about your world, your handbook, your product docs, your notes. In this video we'll fix that by building retrieval-augmented generation, or RAG, from scratch. By the end, you'll be able to ask plain English questions about your own documents and get answers that cite exactly which file they came from. In this tutorial we'll build a small but complete RAG system in plain Python. The idea has 4 moves. We chunk your documents into passages. We embed each passage into a vector, a list of numbers that captures its meaning. When you ask a question, we retrieve the passages whose vectors are closest to your question. And we hand only those passages to the model, so its answer is grounded in your text and can cite its sources. No database server, no framework, just a folder of files and a little numpy. Here's the plan. First, a chunker that splits each document into overlapping passages, so no idea gets cut in half. Second, an embedder that turns each passage into a vector. Third, a tiny local vector store, and by store I just mean a numpy array on disk, no special database needed. Fourth, retrieval. Given a question, we find the nearest passages by cosine similarity. And finally, an answer step that feeds those passages to the model and asks it to cite which document each fact came from. 5 small pieces, and together they're a real RAG pipeline. Let's build intuition for the key idea, embeddings. An embedding model reads a piece of text and places it as a point in a high-dimensional space. The magic is that meaning becomes geometry, passages about similar topics land near each other, and passages about different topics land far apart. Here are documents, pricing, refunds, setup, limits each become a point. We've drawn it in 2 dimensions, but a real embedding lies in hundreds or thousands. The only thing that matters is this: closeness in this space means closeness in meaning. That single property is what makes search by meaning, instead of by keyword, possible. Now retrieval, which is just a distance measurement. When a question comes in, we embed it the same way, so the question becomes a point in the very same space, the star here. Then we measure how close it is to every document point, and we keep the nearest few. Those top matches are the passages most likely to contain the answer. We hand just those to the model as context. Notice what we did not do: we never searched for matching words. A question about getting money back can find a passage titled refund policy, even with no shared keywords, because they sit near each other in meaning. Retrieval is nearest neighbor search, and that's the whole trick. You'll need very little. Python 3.10 or newer and an API key. 2 libraries only, the OpenAI client for embeddings and answers, and numpy for the vector math. A folder of plain text documents to point it at your notes, docs, or a handbook. And access to 2 models, a small embedding model, which is cheap, and a chat model to write the final answer. That's the entire stack. The point of building RAG by hand is to see that it isn't magic, it's a folder, some vectors, and a dot product. Step 1, install. Just the OpenAI client and numpy. There's deliberately no vector database and no RAG framework here, because for thousands or even tens of thousands of chunks, a numpy array in memory is genuinely fast enough, and it keeps every moving part visible. Once you understand this version, reaching for a bigger vector store later is an easy, informed upgrade rather than a black box you adopted on day 1. Step 2, chunking. We can't embed a whole document as one vector, it would blur every topic together and blow past model limits. So we split each doc into passages of a few hundred words. The important detail is the overlap: each chunk repeats the last 100 words of the previous one. That overlap is insurance, it stops an answer from being lost exactly at a chunk boundary, or a sentence gets sliced in 2. Chunk size is the single biggest quality knob in RAG. Too big and retrieval gets vague, too small, and each chunk loses its context. A few hundred words with a small overlap is a solid default. Step 3, embed and store. We walk the folder, chunk every text file, and embed all the chunks in one call. Alongside each vector we keep 2 things, the chunk text itself, and the source file name it came from. That source is what makes citations possible later. Without it, an answer could never tell you where it looked. Then we write chunks, sources, and vectors to a single JSON file. That file is our entire vector store. You build it once, and rerun it only when your documents actually change. Embedding is the one step that costs money, so we don't repeat it on every question. Step 4, retrieval, and this is the whole vector search, in 3 lines of numpy. We load the store, embed the incoming question, and compute cosine similarity between the question vector and every chunk vector at once. Cosine similarity is just the dot product divided by the lengths. It measures the angle between two vectors, so it captures direction, meaning, rather than magnitude. Argsort with a minus sign sorts from most similar to least, and we keep the top few. No database, no index server, one matrix multiply finds the nearest neighbors. For a lot of real projects, this is all the vector search you will ever need. Step 5, the answer, where retrieval becomes trustworthy generation. We take the top chunks, number them, and label each with its source. Then the prompt does two crucial things. It says answer using only these sources, that grounding is what keeps the model from making things up. And it says cite them inline, like bracket 1, bracket 2, so every claim is traceable back to a real passage in a real file. We even tell it to admit when the answer isn't in the sources, because a system that says I don't know is far more useful than one that confidently invents. This is the difference between a chatbot and a system you can actually rely on. Step 6, wrap it in one small command line. Build points at a folder and indexes at once. Ask takes a question and prints the grounded, cited answer. 2 subcommands, and your documents are now queryable in plain English. Because it's a single command, you can drop it into a script, a chatbot, or a scheduled job later without touching the core logic at all. Step 7, the payoff. We build the index once over a docs folder, then ask a natural question: how do refunds work? Back comes a direct answer with a citation, and the list of source files it drew from. You can click straight to bracket 2, refunds.txt, and verify it yourself. That verifiability is the entire reason RAG matters for real work. It doesn't just answer, it shows you exactly where the answer lives, so you can trust it or challenge it. Before you point this at real documents, a few guardrails. Chunk size is your biggest quality lever. If answers feel vague, make chunks smaller and more focused. If they feel fragmented, make them bigger. Always instruct the model to cite, and to say when something isn't in the sources. That one line prevents most hallucinations. Re-embed only when your documents actually change, to keep costs down and your index fresh. Always surface the sources, so a person can verify every claim rather than trust it blindly. And remember that embeddings are derived from your text. If your documents are private, treat the vectors and the API calls as private data too. RAG is powerful precisely because it's grounded. These habits keep it that way. Let's recap the whole build. We chunked documents into overlapping passages so no idea is cut in half. We embedded each passage into a vector, where nearness means similar meaning. We retrieved the nearest chunks to a question with a single numpy dot product. And we answered using only those chunks, with inline citations back to the source files. That's retrieval-augmented generation, a folder of documents, a handful of vectors, and about 60 lines of Python standing between a model that knows nothing about your world and one that can answer questions about it, with receipts. That's a complete RAG system, start to finish. The full code is linked in the description, so you can point it at your own folder of documents and start asking questions today. If this made RAG click for you, subscribe. There's a new AI build every week. Thanks for watching, and I'll see you in the next one.